Hello friends, myself Subhash Nagarse from Sri Digambar Jain Gurukul High School, Solapur. I shall welcome to all of you in this session of ninth Standard Science and Technology. The topic is Reflection of Light Part 2. In this session, we are going to discuss with mirror and types of mirrors and plane mirrors, terms related to spherical mirrors and drawing the reflected rays. So friends, in the reflection of light part first, we have been discussed on the following important subtopics of this chapter. Those are mirrors, types of mirrors, plane mirrors. Today in this session, we will start with plane mirror. Inverted in the mirror. The image of every point on the world is formed behind the mirror at the same distance from the mirror as the point itself. This is called as a lateral inversion. When a person stands in front of a plane mirror, how is the image formed? What is the nature of the image? Friends, when a person stands in front of a plane mirror, the image formed is upright, that is erect one. That is of the same size as the person and at the same distance behind the mirror as the distance of the person from the mirror, but his right hand side appears to be the left hand side in the image and vice versa. This is called as the lateral inversion. So here the image is virtual one. Place two plane mirrors at an angle of 90 degrees to each other. Place a small object between them. Image will be formed on both mirrors. How many images do you see here? Friends, you can see here a plane mirror placed at 90 degrees to each other. Now, change the angle between the mirrors as given in the following table and count the number of images each other. How is the image related to the measures of the angle? Discuss the relationship. Here you could see the three images that you are seeing there. How it is possible? That is, a relation is given here. N is equal to 360 degree upon A minus 1, where N is the number of images and A is the 3. Three images you could see in the adjacent figure. And this is the table that is given in the textbook. We have to fill up this by using this adjacent formula. Friends, let us see that check if the number of images that you obtained for different values of the angle is consistent with the above formula. If we keep the mirrors parallel to each other, how many images will you see? Friends, here we can see the different angular measures where 120 is the angle. At that time you are getting only 2 images because 360 upon 120 is the 3. 3 minus 1 is 2 images. When kept 90 you are getting 3 images that you have already seen. 60 degree, if it is, you are getting 5 images. 45 degree, at that time there will be 7 images. If it is 30 degree, you are getting 11 images. If you go on like this, when the mirrors are parallel, the angle will be becoming 0. At that time you are getting infinite images. So friends, statement, in order to see the full image of a person standing in front of the mirror, the minimum height of the mirrors must be half the height of the person. You could see here how it is looking. In a figure at this 11.4, the point at the top of the head, the eyes and the point at the feet of the person are indicated by H, E and F respectively. R and S are the midpoints of the H, E and EF respectively. The mirror PQ is at a height of NQ from the ground and is perpendicular to it. Therefore, PQ is the minimum height of the mirror in order to obtain the full image of the person. So for this, RP and QS must be height of the mirror PQ is equal to RS, which is equal to Rs can be written as Re plus Es. So which we can write He by 2, that is Re half of this one, plus Es, that is Ef by 2. So which could be written as Hf by 2, that is half of the person's height. Friends, now let us see what we mean by spherical mirrors. You must have seen the mirrors displayed in the laughing chambers in a fair. Your face appears distorted in these mirrors. Why does this happen? These mirrors are different from the mirrors we have at the home. They are curved. The images formed by the curved mirrors are different from those formed by plain mirrors. Because of this, we do not see the similar images in these mirrors. So you could see here how the images are formed by curved surfaces. The rear view mirrors in a car, which enable drivers to see the vehicles coming from behind, are curved mirrors. You could see here how those are to be formed. If we cut a rubber ball into two parts as shown in the adjoining figure, we can see that each of the two parts has two types of the surfaces. Generally, spherical mirrors are part of the hollow glass sphere like the part B in the figure. The inner or the outer surface of this part is coated with a shiny substance to produce a spherical mirror. Reflection of such light takes place either from the outer or inner surfaces. Thus, there are two types of the spherical mirrors as described below. That is, there are two types of the spherical mirrors. That is, a concave mirror. If the inner surface of the spherical mirror is the reflecting surface, then it is called as the convex mirror. So friends, terms related to spherical mirrors, let us discuss those one. You could see here in the adjoining figure how the spherical mirror is to be formed, and following are the different terms. First is pole. The center of the mirror surface is called pole. P is the pole of mirror in the figure. You could see. Second, center of the curvature. The center of the sphere of which the mirror is a part is called center of the curvature of the mirror. C is the center of the curvature of the mirror that you can see in the figure. Third, radius of curvature. The radius of the sphere of which the mirror is a part is called radius of the curvature of the mirror. The length CP, you could see in the figure, or length CA in the figure is nothing but a radius of the curvature of the mirror. Fourth one, principal axis. This straight line passing through the pole and the center of the curvature of the mirror is called its principal axis. PM is the principal axis of the mirror in the adjoining figure. Principal focus. Incident ray which are parallel to the principal axis of the concave mirror after reflection from the mirror meet at a particular point in front of the mirror on the principal axis. This point F is called the principal focus of the concave mirror. In the case of a convex mirror, incident ray parallel to the principal axis after reflection appears to be come from the particular point behind the mirror lying along the principal axis. This point between the pole and the principal focus of the mirror is nothing but focal length. This distance is half the radius of the curvature of the mirror. Drawing the reflected rays. Friends, you can see in the adjoining figure how the rays are to be reflected. How do we determine the direction that an incident ray will take after reflection from a spherical mirror? In the adjoining figure 11.8, Mn is a spherical mirror and ray AQ is incident on it. CQ is a radius and therefore a perpendicular to the mirror at Q. Thus, angle AQC is the angle of incidence. According to the laws of reflection, angle of incidence and angle of reflection are both of the same measure. Thus, while drawing a reflected ray QB angle CQB must be equal to the angle AQC. We can study the images produced by spherical mirrors by drawing ray diagrams. A ray diagram is the depiction of the path taken by light rays. To draw a ray diagram, we use the following rules, which are based on the laws of reflection of light. Rule 1. If an incident ray is parallel to the principal axis, then the reflected ray passes through the principal focus. Rule 2. If an incident ray passes through the principal focus of the mirror, the reflected ray is parallel to the principal axis. Rule 3. If an incident ray passes through the center of the curvature of the mirror, the reflected ray traces the same path back. Friends, these three laws first rule is explained. In the second, you could see the rule 2, and in the third, it is explained with rule 3. By observation of this, you can easily understand the three rules of reflections. Friends, what we have been discussed today in this session is plane mirror, spherical mirrors, terms related to spherical mirrors, drawing the reflected rays. Friends, you should not forget the famous words of Charles Darwin. Science consists in grouping facts so that general laws or conclusions may be drawn from them. Very nice wording. So friends, if you like this video, please subscribe, share with your friends, and don't forget to press the bell icon. With these words, I would like to say thank you.